Hello everyone, welcome to the course of Theory of Computation. Today we are discussing the topic formal language. This is the concept in module 2 of Theory of Computation of third semester BCA of Calicut University. Then, what is a formal language? A formal language consists of words whose letters are taken from an alphabet and are well formed according to a specific set of rules. So we have already discussed about languages and theory of languages. So a formal language is a well formed form, and it is developed using a specific set of rules, and whose letters are taken from an alphabet. There will be a set of alphabet, and it is formed according to a specific set of rules. The formal language is a set of strings or symbols together with a set of rules that are specific to it. The alphabet of a formal language is a set of symbols, letters or tokens from which the string of languages may be formed. We have to give a set of alphabet from which a formal language is used. It consists of not a set of strings or a set of symbols or a set of strings or symbols. Along with the set of strings or symbols, we have to specify the rules to form the formal language. So the string formed from this alphabet is called words, and the words that belong to a particular formal language are called well formed words. So using this alphabet, that is a set of strings or symbols that can be used in the language, and with the set of rules that for creating the language, for creating the strings or words in the language, we are creating the some words that can be that by the rules that are specified to create a formal language. So that words are known as well formed words. Then this is the definition of a formal language. A formal language L over an alphabet set sigma is a subset of sigma star, that is a set of words over that alphabet. A formal language L is a set of alphabet, sigma is a subset of sigma star, that is set of words over that alphabet. So when we are giving a set of alphabet, there may be a superset, that is sigma star, and we can create a formal language L over an alphabet that can be a subset of sigma. Set of words are grouped into expressions, whereas rules and constraints may be formulated for the creation of well-formed expressions. Using these words in the formal language, we can create expressions and rules and constraints for this developing these expressions or formulating these expressions. Can be also we are giving the rules and constraints for developing an expressions. For example, consider the formal language L over the alphabet, or the set of alphabets are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the numbers decimal. That is decimal numbers, and two symbols, that is plus and equal to. And these are the rules for creating strings in the formal language over the alphabet sigma, or over the alphabet set sigma. Every non-empty string that does not contain plus or equal and does not start with 0 in L. So in this particular formal language, a string cannot be start with plus or equal to symbol or 0, the number 0. And the string 0, there may be a string with only one 0, that is acceptable by the formal language. So the first rule is any string does not contain plus or equal to symbol, and it may not be start with 0. That is, every non-empty string must be start with the numbers 1, 2, 3, 4, 5, 6, 7, 8 or 9, and it cannot contain the symbols plus or equal to. Then there may be a string with that is 0, that is only one 0 in L. The string containing equal to is in L if and only if there is exactly one equal to and it separates two valid strings of L. And the next rule is, the third rule is, if there is an equal to symbol in the formal language, there must be exactly one equal to, and it should be separate. It should separate two valid strings of L. That is, the strings which are developed using, or strings which are created using, or words which are created using the rules of formal languages. That is the valid strings. So if there is an equal to symbol or equal to symbol in the L, then there must be exactly one symbol and it should separate two valid strings of L. Then a string containing plus but not equal to is in L if and only if every plus in the string separates two valid strings of L. Like equal to symbol, there can be a plus symbol, but it like equal to symbol, it also should separate two valid strings of L. No strings in L other than those implied by the previous rules. These are the rules which have to be used to form for a string in the formal language L over the alphabet set given here. So this is an example for a formal language. We have an alphabet set and these are the rules. These are the 5 rules to form for a word or a well formed word in the formal language. Okay. Then under these rules, the strings 23 plus 4 equal to 555 is in L. But the string equal to 234 equal to plus is not, because here it is a valid string. That is, 23 is a valid string in L and 4 is a valid string in L, and as per the rule the plus symbol must separate two valid strings in L. And also if there is an equal to symbol, it should separate two valid string. This 23 plus 4 and 555 is valid in L. So and this equal to separates these two valid strings in L. So this is a valid string, and there is a rule that if there is an equal to symbol, then in every non-empty symbol does not contain start with or does not contain a equal to symbol, or cannot be start with an equal to symbol. It should start with the digits other than 0. So this is invalid. This formal language expresses natural numbers, well-formed additions and well-formed addition equalities, but it expresses only what they look like, the syntax, not what they mean. This means every formal language express this the given example expresses natural numbers and its addition, but it expresses only what they look like, not their semantics. That is, it may be there may be that the first for example, in the given example 23 plus 4 in normal natural numbers case, 23 plus 4 is 27, and here we have written 23 plus 4 equal to 555. Actually we cannot read it as 23. We have to read it as 2 3 plus 4 equal 1 5 5 5 5. Okay, that is what they have here. It is written as it expresses only what they look like. That is, it is only the syntax to form a formal language, not what the exact meaning of that particular string or that particular expression. That is why I have said in using the normal natural numbers, 23 plus 4 is equal to 27. But here we can write as like as that given in the example shown above. For instance, now nowhere in this rules is there any indication that 0 means the number 0, plus means addition, and 23 plus 4 equal to 555 is false. If we have to consider this as a natural number, then we have to indicate that 0 means the number 0, 1 means the number 1, and so on. And also plus means addition, equal to, and also that these are full. But in formal language, what are the rules given to form a formal language? That is only that rule must be applied to form a string. Okay. Then these are the difference between natural and formal languages. In natural languages are, for example, English and Malayalam. Formal languages are C, C++, Java, Pascal, right? Like the languages used for computer programming. Then in natural languages, expressiveness is high, and formal language there is a well defined syntax, and in natural languages no extra learning is required, but in formal languages there may be an ambiguous semantics, and in natural language there may be ambiguity, and formal languages can be processed by a computer, and large problems can be solved in formal languages. And these are some limitations of formal languages, that is high learning effort, it is limited expressiveness, low acceptance, and these are the some negatives of or demerits of natural language. That is, there may be ambiguity in different sentences or different statements or different strings, vaguenesses can be there, consistency hard to check. It is hard to check the consistency of a natural language sentence or natural language strings. Okay, thank you for watching.